so we are on our last section of the semester. This is actually going to be known as 3.4. So we talked about the unit circle in class. We talked about all the different values of it, that sine is the x value, so forth and so on. So now we're going to talk about some of the properties that result from that. So all of this originates from understanding the unit circle. So recall that our sine of any angle was actually our y value. The cosine was our x value. And then tangent was y divided by x. Now remember, for SOHCAHTOA, sine is actually the opposite over hypotenuse. So like if I have a triangle here, the opposite is this y value and the hypotenuse is here. Well, in the unit circle, the hypotenuse is 1. So if you were talking about something that was bigger than the single unit circle, then it would be over r, the radius. But our radius is 1 here, so of course I don't have to put it over 1. Cosecant is the reciprocal of that. So a reciprocal of an integer is 1 over that integer. So this one would be 1 over x. If I already have a fraction, the reciprocal would be x over y. Okay. Our domain and range is getting us ready for graphing, but we're actually going to pick up graphing at the start of next semester, so we may revisit this section, but we're going to keep on going for now. All right, so we want to evaluate without a calculator by using the period of a function and the values on the unit circle. So, we want to think about, remember an entire, like where are we on the unit circle is what I'm asking. So remember a full circle is 2 pi. So how many times around could I go and how many would I be have left over to find something equivalent here? So 23 pi. So what I would do is keep subtracting 2 pi, which is actually 6 pi over 3, right? That's the equivalent. Until I got something that was less than 2 pi. So 23 minus 6 is 17 pi over 3. Subtract 2 pi again. Okay. And then have to subtract even again. So that is 5 pi over 3. So notice I had to do that 3 different times. Some of us can do that in our head easier than others, so I kind of wanted to show the long way thought process of that. So sine of 5 pi over 3. If you look on your unit circle, the y value at 5 pi over 3 is negative square root of 3 over 2. Please realize it is not uncommon to have that unit circle memorized. If we were in a normal setting and not the virtual world, I would be quizzing you on whether you have this memorized. It is important to have it memorized for calculus. If you're not going on to calculus, then yes, it's just maybe something mindless that I'm making you memorize. But just realize that it is expected to remember. All right, so cosine's going to work the same way. This time it'll be subtracting 8 pi over 4. So I'm just finding a common denominator that divides to get 2. So whoops, that's not right. Math is important, right? So subtract again to get 1 pi over 4. So this is really, I am at the coterminal angle of that, which is pi over 4. And cosine of pi over 4, so that means on the unit circle, the x value at pi over 4 is square root of 2 over 2. And instead of just taking my word on it, maybe try actually looking at that on the unit circle so that you are making that connection, okay? What about tangent of negative 9 pi over 2? So negative 9 pi over 2. This time we're going to add 2 pi. So that's actually going to be okay. I can actually stop there because I know that negative pi over 2 is just a negative 90-degree angle. So that's actually this point right here, which is 0, negative 1. That's pretty simple. Okay. So tangent of negative pi over 2 is the y value, which is negative 1, divided by the x value. And remember, it is never okay to divide by 0. Therefore, it is possible that for tangent, you get undefined, meaning there's a spot where it cannot happen. Okay. All right. And if you're still listening, then we're going to do the same thing here. Negative 29 plus 12 is negative 17 plus 12 is negative 5, which is 7 pi over 6. And so sine of 7 pi over 6 is equal to negative 1/2. So to link this back to your first section, all of these that we found were coterminal angles. So that's why coterminal angles were important, understanding that they're all happening at the same spot on a circle. All right, so you have a reference page and a 4 problems to try before meeting me back here